Now, a brief discussion of immutability. The word immutable means unchangeable or changeless. The word variable means apt or liable to vary or change. So how can we possibly say that functional programming languages have immutable variables? To explain, I will need the assistance of Van Halen. Pictured is Van Halen, circa 1984. The man on the left is David Lee Roth. He sang their hit song, Jump. In 1985, Van Halen replaced David Lee Roth with Sammy Hagar. He sang their hit song, Why Can't This Be Love? Let's see how a programming language like Python might deal with this. Here we are up in 1984, and Van Halen consists of David Lee Roth, Eddie Van Halen, Alex Van Halen, and Michael Anthony. If we ask Python who sings a song, it's always going to tell us it's the lead singer of Van Halen. So if I ask it who sings Jump, it'll tell me David Lee Roth. Now here we are in 1985. All of a sudden, David Lee Roth has been replaced with Sammy Hagar. And here you can see the replacement happened. Now if I ask Python who sang Why Can't This Be Love, it'll tell me Sammy Hagar, because he's the lead singer of Van Halen. The problem is, if I ask Python who sings Jump, it's going to tell me the lead singer of Van Halen, which is Sammy Hagar. Python has completely forgotten that Van Halen used to have David Lee Roth. Now let's look at how some functional programming languages, which do support immutability, might handle the same situation. On the left here, I have the same situation programmed in something called standard ML. We start by defining Van Halen as David Lee Roth, Eddie Van Halen, Alex Van Halen, and Michael Anthony. We declare our function who sings, and then we ask who sings Jump. Then we redefine Van Halen as Sammy Hagar, Eddie, Alex, and Michael, and ask who sings Why Can't This Be Love, and Jump. Let's see what happens. All right, so here's what happens. When I asked it who sings Jump, it gave me David Lee Roth, like you'd expect. But even though I told it right here, Van Halen is Sammy Hagar, Eddie Van Halen, Alex Van Halen, and Michael Anthony, it still tells me David Lee Roth saying, Why Can't This Be Love? And Jump. Let's take a look at the code and see what's going on. Here on this first line, I am binding this list of strings to this variable, and that binding is immutable. What that means is, going forward, every time the code sees Van Halen, it can replace it with this list of values. So when it gets to this function who sings, it's as if it stuck it right in there, and that value is immutable, right? So when I ask who sings Jump, it's going to tell me David Lee Roth. Now when I redefine Van Halen here, it doesn't change this value here because it's immutable. What it does is creates a whole separate reality in which Van Halen now means this. So when I ask who sings Why Can't This Be Love, it's going back to our old reality and finding David Lee Roth. Now let's look at a different functional language, Racket in this case. Here we've got the same situation coded. We define Van Halen as a list of strings. We define our function who sings. We ask it who sings Jump. we redefine Van Halen, replacing David Lee Roth with Sammy Hagar, and then we ask it, who sings? Why can't this be love? And here's what happens when we try this in Racket. What Racket says is you can't redefine Van Halen. You said Van Halen was David Lee Roth, Eddie Van Halen, Alex Van Halen, and Michael Anthony, and that's what it's always going to be. It's immutable. So this leaves us with at least 3 different ways of dealing with change. There's the Python approach, which I think of as the Mr. Short-Term Memory approach. Whatever the last thing you told me is, that's what I'm going to go with. There's the standard ML approach, which I think of as the hippie Muppet character like Janice approach, where every time you make change, you create a brand new reality that carries forward until the next change. And then there's the grumpy old man approach of Racket, the real Dodgers never left Brooklyn approach that simply denies change.